Before I start, I invite all our subscribers to solve one riddle. Which planet is so light in weight that it can float in a swimming pool? And which same planet in the solar system is the most different from the others? Here's a hint. It's named after the Roman god of agriculture. That's right, it's the majestic ringed Saturn. Despite the tremendous remoteness of the sixth planet from Earth, research probes have periodically been sent to it. In particular, the object was studied in detail by the Cassini interplanetary spacecraft. It wandered through outer space for 2 decades, closely examining Saturn and its moons. This story began on October 15, 1997 at Cape Canaveral. The ship carrying the Huygens descent module was launched from there. The probe had serious tasks to accomplish: the study of Saturn itself, its rings and satellites, as well as handling the descent of the Huygens to the planet's largest satellite, Titan. And the probe brilliantly managed all its duties. How many years did it take Cassini to reach its target, Saturn? To do this, the device resolutely traveled mile after mile for 7 whole years, until June 30th, 2004, when it entered the orbit of the giant planet. For many years, scientists around the world followed the activities of the spacecraft with bated breath and witnessed the amazing discoveries that it made. So, what did Cassini discover on and around Saturn? The probe carefully studied the satellites of the planet, sending images of newly discovered sites to Earth, literally plunged into the ice rings of the giant, and also studied the stormy atmosphere, discovering an unusual hurricane at one of Saturn's poles, something for which no analogs exist in the entire solar system. The last days of the probe were no less captivating than its life. They programmed a 2-part finale. First, scientists planned a series of probe flights between the Saturnian rings, and this was a very risky maneuver. But contrary to fears, Cassini did a great job. But in addition, for part 2 of this finale, a sad mission was assigned to the device. What exactly was it? Cassini had to sacrifice itself so as not to pollute the satellites of Saturn with its possible fall, where, according to some astronomers, certain life forms could possibly be developing. And by the way, this applies not only to Enceladus with its subglacial ocean. In other words, the Cassini life cycle was very rich and eventful, and the probe didn't lose contact with Earth's scientists until the very end. So, what was the mission this interplanetary traveler is famous for, and where did the device finally meet its demise? I'll tell you all about it in a few moments. Thanks to Cassini, we've greatly expanded our knowledge of Saturn's rings. In past centuries, they were spoken of in the singular form because it was believed that this was some kind of big hoop hovering around the planet. This, in particular, was mentioned by Christian Huygens, whose name was later given to the descent vehicle, which was part of the Cassini AMS. The rings of Saturn were first discovered by Galileo Galilei in the 17th century, and since then, countless fantastical stories were hypothesized by scientists regarding this strange formation. However, I digress from the mission of the legendary device. Thanks to Cassini, numerous myths were dispelled, as astronomers discovered that the rings are actually composed of ice inclusions of various sizes, with impurities of dust and organic compounds. There are 4 rings, and the last of them is thinner than the others. Their diameter is huge, about 250,000 kilometers, while the thickness of the formation never reaches even 1,000 meters. In many places, there are voids, or peculiar mountainous agglomerations consisting of stones and ice. But overall, it's extremely heterogeneous, and the amount of matter in the rings is so insignificant that if all the stone and ice blocks were united into a single big lump, its diameter wouldn't exceed 100 kilometers. But these parameters could change depending on the intrusion of other space objects, for example, flying comets. Cassini also studied the moons of Saturn, and there are an incredible 82 of them. Some astronomers compare Saturn's system with our solar system, where the rings symbolize the asteroid belts. Isn't that quite the original analogy? Imagine the essentially fragile piece of metal named Cassini, crammed with hardware, hurtling at over 120,000 kilometers per hour towards its final destination, the vast, hazy, gaseous Saturn. Might you think we're describing a direct flight to the giant planet? No, this is in fact what the probe's death in Saturn's atmosphere looked like. It was the fate that scientists prepared for it, or rather, they were forced to do so. But before the death of the device, there was still a lot to explore, so let's not get ahead of ourselves. After its arrival in 2004, Cassini became the first artificial satellite of the gas giant, flying around it at a speed of 15 kilometers per second. During this time, it approached many of the planet's satellites. For example, Snow White and Enceladus, mysterious Titan, and others. But what was the most surprising discovery in the entire mission of the interplanetary vehicle? This is undoubtedly the legendary hexagon of Saturn, a giant stable hurricane located at the north pole of the planet. The hurricane's diameter is 25,000 kilometers. That means this storm could easily absorb several such cosmic bodies as our Earth, which is just 8,000 kilometers in diameter. Cassini found that the vortex literally grows into the atmosphere of the planet, pushing over 100 kilometers into it. In fairness, it should be noted that the hexagon was seen earlier by the Voyager spacecraft, but due to the extremely poor quality of the images, no one paid much attention to the structure. Cassini, which first photographed the extraordinary storm from a distance of more than 2 million kilometers, demonstrated to the whole world that we're dealing with a hurricane of planetary scale and enormous power. At the same time, the craft found that unlike the stable shape of its funnel, its color depended on the season and changed from bluish to golden. By the way, on Saturn, autumn follows summer, turning into winter and then spring, according to the same principle as here on Earth. This is facilitated by the tilt of the poles. When the northern part of the planet receives more sunlight, the hurricane, bathed in rays of light from our sun, acquires a golden halo. In winter, accordingly, the storm turns dark blue. So, how do scientists explain the appearance of this titanic hexagon? Most likely, it was helped along by the movement of atmospheric masses during Saturn's rapid rotation. But what about the enchanting death of Cassini? Has it brought any benefit to science? Yes, and it's huge. Returning to the hexagonal vortex, the probe photographed it again when its mission was coming to an end. It also discovered stone rains on Saturn, provoked by the permanent destruction of the planet's rings. When dust and ice particles enter the giant's atmosphere, despite a decent distance, this happens regularly, they break up into small fragments. So tons of ice and stones fall on Saturn every second. There's no conceivable umbrella that could offer protection from such a devastating rain. How does this threaten the rings of Saturn? Obviously, if the situation doesn't change, then very soon the planet will lose this distinctive feature. And it doesn't matter that the rings contain particles up to 100 meters in diameter, they too can fall over time. Do you wonder what the reason is for this strange phenomenon? It turns out that ice particles have a constant charge, and the core of Saturn is surrounded by so-called metallic hydrogen, which generates the planet's magnetic field. Both structures are attracted to each other, like hair to a rubbed balloon, hence the attraction and destruction of the rings, gradually giving up their particles to the planet. There's a mystery that Cassini was only able to solve at the end of its mission. And here I'm talking about the age of the rings. Astronomers were puzzled for a long time. Are the rings younger than the planet, or were they formed at the same time it was formed? It turns out that the age of the rings varies from 10 to 100 million years. So when life first appeared on Earth, and for most of its existence, Saturn didn't have its rings. Such conclusions were arrived at by scientists after obtaining data on the size and brightness of these objects. If the rings were older, then their brightness would decrease significantly due to the systematic accumulation of space debris. By the way, according to one theory, the rings appeared when Saturn attracted a very large icy satellite. As a result, the giant planet simply tore the object into small fragments gravitationally. To the honor of Cassini, it's worth remembering that even dying in the poisonous atmosphere of Saturn, it continued to fulfill its mission and was able to capture the clouds of the gas giant, achieving the closest possible distance to them. Thanks to this tiny but persistent and fearless apparatus, we got to know huge, distant Saturn better. Through the eyes of the probe, we saw a magnificent whirlwind of epic proportions, learned about stone rains, and also were able to view the satellites and rings of the planet, revealing some of their secrets along the way. Meanwhile, Saturn continues to rotate in the company of Tethys, Iapetus, Mimas, Enceladus, Titan, and the other cosmic bodies that organically complement it. It's likely that many more missions will be organized to the giant planet, and perhaps our descendants will even spend their holidays in its orbit. But the achievements of Cassini will never fade. If you enjoyed the video, we invite you to subscribe to our channel and like this video. And we, for our part, promise to create even more interesting content about the amazing things hidden in the depths of our universe.